Oh, hey, didn't see you there. I'm JP Redmond.
And I'm Casey Smith. And this is our DOM project, the pool lift. So, for our design, we decided to go ahead and make the pool lift electrical for a couple of reasons. One, with this cylinder and everything, it's controlled by a geared motor. So if anything messes up, the shaft will stay at its extended rate or wherever it's at. It won't plummet. We don't have to worry about hoses or seals like we would anything else. So go ahead and get into the electronics. We have a solar panel. This will allow the battery to keep a maintained charge and kind of keep it maintenance free from the family. We'll have it mounted to the deck like so. Going over to our control box here, we have a voltmeter that helps to monitor the voltage in the battery since this is controlled by DC power supply. Moving on, we have our linear actuators. We have two of them. This one will be the rotational. This will be attached to the deck, and another mount will be attached underneath the pool lift to this shaft. There will be a lever arm, and this will help extend to rotate it around since we only need about 90 degrees of rotation. For this box, we also have a shut-off switch, so that way if anything goes wrong, they're able to go ahead, shut it off without any problems, kill power to the whole system. Moving on to our remote. We have a two-switch system here. The switch on the left controls the motor direction. So right now we're on our lift, so our up, we'll go ahead and extend it. And then our down, obviously, we'll bring it down. There's limit switches within these to keep the screw within from coming out. Our other switch, toggle switch, will be we'll transfer all the power from here to our rotation, and we will have out rotation and then back in. Now, moving on to the structure, JP will pick it up from here.
So there are several things we had to choose for our structure. First of which is we chose an aluminum tube to hold the actual chair. There are two reasons for that. One being that aluminum won't corrode and rust like this steel will, so if it goes in the water, it'll be perfectly fine to last the time. Secondly, aluminum is much lighter than steel, so since this is the farthest piece from the actual base of the pool lift where it is being mounted, it'll be lighter and have less moment pulling on the actual deck where it's mounting. Another design aspect is the dual stabilizer arms. Using two stabilizer arms allowed us to have a very level position for this chair. So whoever is sitting in the actual chair will be nice and level whether they are rotating left and right and they are going up and down. Another design consideration was the actual placement of this actuator. We had spoken with the family and they wanted the child to be 16 inches displaced into the water. So we chose the mounts to be here and here, which when the actuator is fully compressed, it'll drop the beam where the chair is mounted 16 inches into the water. And we also have slight adjustment for child growth to where it can raise and lower a few more inches into the water. Now, in terms of another structural design, we had to figure out a rotation mechanism. To do that, we had chose a flange right here, where on the underside we have milled out 12 different holes around in the base of this flange, where we had taken what is traditionally used inside of ball bearings, big hard stainless steel balls, and pressed them inside it. They are used to help this rotate rather easily. Now on the bottom side, this will be under the deck. This tubing has inside it oil embedded flange sleeve bearings. These sleeve bearings are high tolerance and the shaft goes perfectly inside of them and allows for rotation. So when that lever arm connects right here, there is grease fittings here and up top, and these balls will be greased as well and allow this thing to smoothly rotate left and right and then be lowered by the actuators.
Okay, as for the chair, we mounted it onto the aluminum